All right, everybody, how's it going? Hope everybody out there is staying safe and healthy and practicing proper self-isolating techniques. I guess this is not where we've seen this going, but we'll do our best to make it work and get you through and make sure that you have the skills to be successful next year. Kind of miss my favorite class, but don't tell anybody I said that. So I'm gonna make a video here just to do a quick recap on solving inequalities because I'm gonna send out a Google form quiz on that here soon, and as well, just this video can serve as a review for the unit. And so this is the second part of the second unit we were looking at. I'll make another video on just solving regular equalities after. And so we're talking about solving inequalities. So inequalities is where we have some equations that have inequality signs in them. So greater than or equal to, greater than, less than or equal to signs in them. And so solving equalities can come in two forms. We looked at when we have one variable and making sure we solve accordingly. And then if we have two variables and how we solve accordingly. So one variable is going to look something like this. So if I have like a question like x squared plus 7x plus 6 is greater than 0. And like, where is the solution that would satisfy those conditions? Well, because we only have one variable in here, we are only going to put an answer kind of in like one dimension, which doesn't really make sense, but one dimension. So we'll look at how to solve one variable questions. Two variable questions is now if I replace this 0 plus 7x plus 6 greater than y. So the same equation, but now I have two variables in that. And when I have two variables, I now have to shade in some sort of two-dimensional area that can satisfy both parts of that equation. And so let's just go look at the different types of examples we were looking at. And then if you guys have questions, you can always post them. So here's the first example. So it says, sketch the following inequalities. So as soon as I look at this, I can look at this and say, well, I have two variables. I know I'm going to have to shade in some sort of two-dimensional, area when I solve this. So to solve, the first thing we're going to do is just graph it. So graph that. If it's a linear function, graph your linear function. If it's a quadratic, graph your quadratic expression. And we should be pretty comfortable by now dealing with quadratics. So x minus 3. So I start off when I'm drawing a linear function. I'll go to 3 on the y-axis. That's where I start. My slope is 1, which means I'm going to go 1 up and 1 right to get to the next point. So 1 up, 1 right, 1 up, 1 right. 1 up, 1 right, 1 up, 1 right, 1 up, 1 right. And it's a really bad line. I would connect those. One thing I guess I should say to remember here is depending on what kind of inequality is going to depend how our line looks. If it's you can equal, right, you're going to have that solid line. If it's an inequality that you can't equal, we would represent that by a dashed line. And so that's, in this example, why I had chose to choose a solid line here. Once I've graphed my function, and remember if you're graphing, you want it like y equals blah, blah, blah. The second thing I want to do is substitute a point to verify where I'm going to shade in. So substitute a point to help shade. Now, if we can, I'm always going to choose the point 0, 0. Just makes my life easiest if I can use that one. So I'll choose this point of 0, 0 and substitute it into this equation. And so what I do is 0 less than or equal to 0 minus 3. So I ask myself, is 0 less than or equal to negative 3? Is 0 less than or equal to negative 3? No, it's not. Which means that point is not part of the solution. So I would need to shade everything on the other side. And that was how I would sketch that inequality. So let's look at a linear function that's a little bit more difficult. Negative 4x minus 4y is greater than 8. Now, looking at that, I don't really know a whole lot about that function. I can look at it and figure some stuff out, but the best thing for me to do is get y by itself. So to do that, I'm going to add 4x to either side. So add 4x, add 4x. So I'm left with negative 4y is greater than 8 plus 4x. And that looks like a 7, but that's a greater than sign. To get y by itself, I have to divide by a negative 4. And then this here comes another big part. We're looking at, rearranging or solving inequalities algebraically, is when you divide by that negative number on an inequality, we have to flip the sign. So this is going to become y is now less than what's over here, so which is negative 8 divided by 4 is a negative 2. And 4 divided by 4 is negative 4 is a negative 1. So negative 2 minus 1x. So to sketch that function, I would go to negative 2 on the y-intercept. And I have a negative slope, so my slope is negative 1, which means I'm going to go 1 down and 1 right to find the next few points. So 1 down, 1 right, 1 down, 1 right, 1 down, 1 right, 1 down, 1 right, 1 down. Few points. Okay, and sorry, I can't equal that number because there's no equal sign here, so it should be a dashed line that connects all the points that I've sketched. The last thing I need to do is determine what area I'm going to shade in, because I have two variables here, and I'm going to choose the point 0, 0 like I always do. Now I can choose to substitute 0 and 0 into here, or I can substitute 0 and 0 into there. It doesn't really matter. I'm just going to do it into here because I know that I didn't mess up rearranging. So when I put this in, negative 4 times 0 minus 4 times 0, is that greater than 8? Well, the question is 0 greater than 8? No. So I'd have to shade in everything on the other side because that point does not fit into the solution set. So that's linear inequalities. We'll do the same thing here with some quadratic expressions. And the process is exactly the same. I'm going to go sketch it. Once I've sketched it, I'll take a point, substitute it in, and determine where I'm going to shade from there. So here is my inequality. Y is greater than or equal to x minus 5 times x plus 1. This setup as is giving me the y-intercepts. The x-intercepts. My x-intercept is going to be at 5, positive 5, so the opposite here of this, and minus 1, so right here. I know there's going to be an x-intercept. I could multiply this out to give myself a little bit more information here. So that's equal to x squared plus 1x minus 5x minus 5. So that's x squared minus 4x minus 5. So I know there's a y-intercept at negative 5. And if I want to complete the squares, I could do that just so I can figure out exactly where the vertex is. So I could go x squared minus 4x. So I take that, divide it by 2, and square it. So negative 4 divided by 2 and square it is 4. So I plus 4, minus 4, and minus 5 here. So there's going to be, and now I need to complete the squares with this. So that would be x minus 2 all to the power of 2 to make a perfect squared trinomial. And I kick that out, times it by 1. So minus 4 minus 9 is minus 5 is going to be minus 9. So there would be a vertex at 2, 9. So 2, 9. And once I have about 3 points, that should give me more than enough information just to kind of sketch my function here. Please make sure if I'm like giving you an assignment, you sketch at least 3 points. Be my preference. Now that I have my function, I've sketched it, I'm going to do the same thing where I'm going to take 0, 0 and substitute it into my equation. So I'm asking myself, is 0 greater than or equal to 0 minus 5 times by 0 plus 1? So is 0 greater than or equal to negative 5 times negative 1? So is 0 greater than or equal to negative 5? Yeah, it is. So I would shade everything in here because that is part of the solution set. All right, I would invite you to take a second right now and try example D on your own. So pause the video, do whatever you have to do to sketch this function, and then turn the video back on and make sure you're correct. So if I'm going to sketch this function, I could factor it, I could complete the squares, whatever you want. I'm just going to complete the squares. So to do that, I'm going to take out a negative number. So now I'm left with negative x squared plus 4x. And I want to complete the trinomial with that. So divide that by 2 and then square it. So 4 divided by 2 squared is positive 4. I need to add 4 and minus 4 at the same time. And then outside of the brackets here, I'm going to keep this 12. So this part right here will create the perfect square trinomial x plus 2 squared. The leading coefficient is that negative 1 that I kind of brought to the outside. And then when I kick out this negative 4, I have to times it by negative 1. So that's going to be a plus 4 on the outside. So this is plus 16, which is not going to sketch on here very well. That's all right. Make it work. So I'm going to have a point, or my vertex is at negative 2, comma 16. I also know from this that this function is going to open down. So I'd have a vertex at negative 2, 16, like somewhere like way up here. From here, I also know I have a y-intercept at 12, so something here. I could go as far as figuring out my x and y intercepts if I wanted to, which would be, what is it, x squared plus 4x minus 12, so 6 and 4, so negative 6 and 2. So function should look something like this. And you can always graph those on your graphing calculator to verify that you're right? I could just put this on my calculator and make sure that my sketch resembles what's there. That's an awful quadratic function. Anyways, I'm going to take 0, 0 and substitute it into here. So is 0 less than negative 0 squared minus 4 times 0 plus 12? So really, I just need to look at the constant. So is 0 less than 12? No, it's not. So I will sketch everything all the way around this function would be part of my solution set. All right, so that's 2 variables. We'll now take a look at solving the inequalities that have 1 variable. And so if you remember, to solve the equalities that have 1 variable, what we need to look for, I need to find the x-intercepts. So if I can factor it or use the quadratic formula, that will give me my x-intercepts. I can give myself a quick sketch and then determine the solution set from there. So let's take a look at the first question. X squared minus 5x minus 6 is greater than 0. So what I'm going to do is factor it. So looking for 2 numbers that multiply to negative 6, because a is 1, and add to negative 5. So 2 numbers that multiply to negative 6 and add to negative 5. That would have to be negative 6 times 1. And so I just separate those because a is 1. So x minus 6, x plus 1. That gives me my x-intercepts. So I could just, if I want, give myself a quick sketch. I know there's an x-intercept at positive 6, and there's an x-intercept at negative 1. Because remember, we make these equal to 0, and it's the opposite of what appears in those factors to find the x-intercept. Now, the other piece of information I need to help me solve this is what direction this opens. So this, because the leading coefficient is positive, is going to open up. So I have a function that kind of looks like this. And now I just need to answer and state my solution. So where is this equation greater than 0? Well, this equation is greater than 0 over here and over here. And I just state my solutions then as such. So here, this would be x. My solution here is x is greater than, and I should 6 because it's from here and over, and it's here and less. So x is less than negative 1. I don't include the equal sign underneath because back in my original question, there was not an equal sign underneath my equality. All right, I'll do B and then I'll get you to do C on your own. So again, the question is going to work the same. I have to find my X-intercepts and then sketch and determine my solution set from there. That's my solution. So in this one, 4x squared minus 9, hopefully you can identify that and say, well, I have to factor that, and I can factor that using a difference of squares. So if I factor that with difference of squares, this becomes 2x minus 9 and 2x minus 3. Square root of 9 is 3, and 2x plus 3 is greater than 0. And so similar sketch. This would give me an x-intercept of 3 over 2, so 1.5. So there's an x-intercept at 1.5. And from here, negative 1.5, negative 3 over 2. It also opens up because this leading coefficient is positive. And there would be my sketch. And the question is asking, where is this function greater than 0? Well, it's actually pretty similar to the question over here. I just need to state my solutions differently. So here, x could be any number greater than 1.5, or x is any number less than negative 1.5. And then I would just, that's my solution. So I would invite you to try C on your own, pause the video, and do the exact same steps that I just did. All right, hopefully you paused it. And hopefully you can look at this question and identify if you're going to factor it, but with just factoring methods, you need to check and see, and not just looking for numbers that multiply to 12, right? We now need to include numbers that multiply to 3 times negative 12 and add to negative 5. So we're looking for numbers that multiply to 36 and add to negative 5. Hopefully you know those numbers off the top of your head. If not, you got to trial and error to get there. Or if you think it's unfactorable, using traditional methods, you can always use the quadratic formula. But the numbers that we're looking at here would be negative 9 times a positive 4. And I need to split my middle term. So this would be 3x squared minus 9x plus 4x minus 12. Where is that less than or equal to 0? And I need to go find my x-intercept. So I'll put brackets around the first 2 terms, last 2 terms, and divide out a GCF. So taking a GCF out of here, which is 3x. 3x squared divided by 3x is x. And 9x divided by 3x is going to give me a negative 3. Same thing in the next set of brackets. My GCF would be a 4. And divide each term by the GCF. So 4x divided by 4 is x. And negative 12 divided by x is negative 3. I should realize that I'm on the same, or I'm on the right track factoring because this is the same. That becomes one set of factors because I now remove that out as a GCF. And what's left in front becomes the other. So I could sketch that for myself. I know that it's positive because my leading, or it opens up because my leading coefficient is positive. And I have an x-intercept at 3 and one at negative 4/3, so negative 1 1/3, so negative 1.3. And it's going to open up. And lastly, I'm just looking for the solution. Where is that less than or equal to 0? That would be this part of the line right here. So my solution now, because I'm between 2 points, remember we put the arrows to the left. I say the lower number. I can equal this function, so negative 1.3 repeating, or negative 4/3, and the higher number, which is 3. So that's solving inequalities with one variable. Very last thing we got to look at is how we can take those and apply these strategies to problem-solving questions. So here's an example. A concession needs to generate $144 or more in revenue. It's offering 2 meal deals. The cheeseburger deluxe meal is $12, and the Mexican meal is $9. So it says, first of all, write an inequality that would represent this scenario. Well, the 2 meal deals, so however much I sell, so let's say 12C plus 9M needs to be greater than or equal to 144. Right? We want to make at least that much money, so however much I sell here has to be greater than that $144. So I represent that as my inequality. Next thing they do for these real life questions is they ask me to sketch them. And they're less than ideal to sketch if I don't have very nice numbers and I have to create my own scale. So the best way to do that is just find the intercepts. And so my intercepts is just like make C equal 0 and make M equal 0. And that will tell you, if I sold no cheeseburgers, what's the max amount of Mexican whatever I'd have to sell. So if I put that into here, this would be 9M144. So 144 divided by 9. M is going to be 16. That's my M intercept. And if M is equal to 0, that's going to be my C intercept. So 12 C144. So divide that by 12. C is 12. So 2 intercepts. Now, where I decide to put cheeseburgers and Mexican meal, it doesn't matter for my axes. So let's say down here is cheeseburger meals. Oops, I can't spell cheese apparently. And Mexican. That just jumped up on me. Mexican. The most I can sell is 16 of the Mexican and 12. Do I have enough? 2, 4, 6, 8, 10, 12. Okay, all right. Okay, so Mexican, so 2, 4, 6, 8, 10, 12, 14, 16, 18. So I have an M intercept of 16. So if I sold only 16 Mexican meals, I could sell no cheeseburgers and I would be greater than $144. Cheeseburger meals cost a little bit more. Oops, sorry, 8, 10, 12, 14. If I sell 12 cheeseburger meals and no Mexican meals, I'd make at least $144. So I could connect these in an awful line. And, well, where am I going to shade in? Do I want to make less money than this, or do I want to make more money? Well, I want to make more money than 144, so I'm going to sell anything over here, including anything that would fall on this line. And so a description of what each intercept represents, I just kind of explained that. This here represents I sell only 12 cheeseburger meals and I sell no Mexican. I'd be able to make my $144, or vice versa with the Mexican meals. Okay? And hopefully we're all okay with creating these equations. That's kind of back to grade 9 and grade 10 creating equations. Okay, so that is the quick review for solving inequalities. If you have any questions, feel free to email me or just comment them on the video. If you haven't already done all of the homework in the homework book, that's up online if you want to do some practice problems on there. Otherwise, the quiz will be coming out and the unit review will be coming out right away. Okay, thanks for listening.